So we're going to be taking a look at something called slope. Slope on a graph is simply the rate of change. So if you think of a situation, for example, let's say you were in a car and the car was traveling at 50 miles an hour, right? Every hour that you go, you'd travel 50 miles. 1 hour, you'd travel 50. 2 miles, you travel, or 2 hours, sorry, you travel 100 miles. 3 hours, 150, and so on, okay? So it's that same amount of increase each time. On a graph, that's called slope. So we're going to look at some things related to slope, how we find slope from a graph, how we can use a slope to graph a line, that kind of thing. Okay. So I'm using a program here called Desmos online, desmos.com/calculator. You can use this, but it works so you can graph some equations and we can look at some slope here. So first one I'm just going to put in an equation over here. Let's do 2x minus 3y equals 6. So we got one in standard form there, and we see the graph. Okay. Now slope is a ratio. Okay, it's a ratio of something called rise to run. Right. If we think about the word rise, if I told you to rise from your seats, you'd stand up. Okay, so rise is an up and down movement. Now if we want to go down, technically it's not a rise, but it's like a negative rise. Run is sideways. Right at the end of class, usually run out your door. Okay, it's a sideways movement. Okay, so all slope is looking at how much does something goes up as it goes over. All right. So I've got this graph here, and I'm going to change one setting on it just to make it a little bit easier to use. Let me get that out of the way. So I'm going to make sure. So right now it's counting by twos. I wanted to count by one, so I'm going to put that in there. Okay. So you can see on here there's a couple of points that are selected. We've got this point and we've got this point. So all I really want to do is figure out my rise and my run. So if you kind of think of these squares as like city blocks, if you're going to walk from this point to this point and you had to stay on the sidewalk, right, I would have to go up here and then I would have to go over. Okay. So my rise, if I count, is just a length of 2. My run is a length of 3. Okay. So when I want to write my slope is simply that ratio. Again, it's rise over run. Okay, so my rise would be 2. My run would be 3. And I would say that my slope is equal to 2/3. Okay, so we found 2 points on the graph. All right, and we calculate that. Now you can see that's that constant rate of change. If I went from here, I could go up 2, 3 more. There's a point. Up 2, 3 more. There's a point. Okay, if I went over here, if I was at this point, up 2, 3 over. Okay, the other one kind of disappears off the screen. But, oh, no, there it is. Never mind. Up 2, 3 over, right? So we see that constant rate of change. Okay, for every 3 we go over, we go 2 up. So slope of 2/3. Okay, let's look at, and that one it's a positive slope, right? Our slope ends up being positive. It's going upward as we're moving to the right. Okay, if I change, I'm going to change just a couple things on here. Let's make this, instead of plus, let's make it minus. So let's do 4x minus 5y equals 20. Oops. That's my bad. Let's make that plus. There we go. Okay, so now we can see a graph that's going downward. Let me move that over here a little bit. Okay, so we'll look at what happens here. Again, we're going to look at the rise and the run. So I'm looking for some points here. I see a point there. I see a point there. So we'll just use our intercepts on this one. Okay, now if I wanted to move, I'd have to go 1, 2, 3, 4, 5, and there. So let's look at our rise and our run. Okay, well, my run, depending on your perspective, if I'm starting here and going here, right, my run is 1, 2, 3, 4, 5 to the right, and that's positive, right? As numbers go to the right, they stay positive. We have the positive numbers on the number line to the right of 0. Okay, however, what happens on my run, unlike last time, I'm going downward. Okay, so I'm going toward the negative numbers. Down is negative, so I'm going down 4. So my run is down. It's important we distinguish between up and down, right? If I was walking on the sidewalk and I went the wrong way, I'd end up at a different spot. So since I'm going down, that's a negative. I'm going from 4 to 0 on my y-axis. Okay, So that's a drop of 4. So again, rise over run. My rise is -4. My run is 5. Okay. And typically we just put the negative out front. So -4/5. All right. Now, if I'd done the other way, let's say, let me change colors here. Let's say I was here, but this time I went 1, 2, 3, 4 up, so +4. Then I went left, that'd be -5, and you can still see we get an overall negative. Okay, so I'd say my slope is -4/5. Again, rise over run. Okay, rise over run. If I did one more, 1, 2, 3, 4, 1, 2, 3, 4, 5. You can see my next point there. Okay. My other one would fall just off the screen. All right, so we're just counting rise and run. It's really that simple. If it's going downward, it's going to be negative. Upward, as you go left, right, is going to be positive. Okay. Now, there are a couple special circumstances. If I have that horizontal line, like y equals 3, for example, you'll notice that there's no rise, right? If I want to go from there to there, for example, I'd go 1, 2, 3, 4 to the right, so my run is 4, my rise is 0. So we'd say that has a rise, that has a slope of 0. Okay, there's no rise, right? And my numerator in the fraction is 0. Now, if I have just an x value, let's say it said x equals 3, that creates that vertical line. Okay, so I've got a point there and a point there, right? If I want to do that, I'd have a rise of 3, a run of 0. Now in math, we don't like zeros in the denominator. If you did 3 divided by 0 on a calculator, you'd get an error message. If you think about the meaning of a denominator, it's how many parts are in a whole. I can't shoot 0 free throws and make 3, right? That's not possible. I could shoot 3 and make 0, but I can't do the opposite. So in this case, we say our slope is undefined, right? If you're skiing on that slope, you're not really skiing, you're more free falling. Okay, so vertical line is going to be an undefined slope. All right, now other things we can do with slope is I could do some graphing. Okay, so let's say I have a scenario where I know a starting point. Okay, let's say it was at 0, -2, and my slope, holy cow, I can't spell, let's try that again. Slope, there we go. Let's say my slope was 2/3. Okay, that's all the information I really need to create a line. So if I have a starting point, I know my rate of increase, my slope, I can create that graph, right? So I go and I plot my point, 0, -2. Okay, my slope is 2/3. So that's just saying from that point, I rise 2 and I run 3. So up 2 over 3. Okay, and I'm just going to do a few here just to make my line a little straighter. Oops, there we go. I could also go left 3, negative, down 2, since they're both negative, right? -2 over, over -3 is also equal to 2/3. A negative and a negative make a positive in this case. So I could keep going with that if I wanted. But I've got all those points now, and you can see they all line up in that row. Okay, so that's a graph of that information. All right, let's do one more of those. See if I can do this without erasing my background here. Nope. Yeah, we'll do this the hard way. Okay, so again, we start with our point. Oops, there we go. Let's just erase this now. There we go. Sorry about that. Let's say we started at 4, 2. And our slope was -3. Okay, so again, I'm going to plot my point, 1, 2, 3, 4, 2. Now, we need a rise and a run, so if it's an integer, we can always put that over 1, right? So that's saying rise -3, so I'm going to go down 3, 1, 2, 3, run +1. You got to make sure 1 is positive. If I go down and left, that's 2 negatives, which make a positive. I could also go up 3, 1, 2, 3, and left 1, right? So I'm either doing this, or I could do this. Again, One part of the fraction's negative, the whole thing is. Okay, but I've got those points there, and I would recommend do at least 3 points. It's a lot easier to draw the line that way. There's your graph. Okay, so start with your point given, and then use your slope to find your next point. All right. Now, other things with slope. Okay, we actually only need 2 points in order to find the slope. All right, so let's say, for example, my points were at 0, 2, and 3, 6. Okay, 0, 2, and 3, 6. I'm going to put that picture back in there for this, so give me a second here. There we go. Move it out of the way. So let's graph those just to kind of see. We're going to try and do it without a graph, but just so we can kind of see what's going on. So 0, 2, 1, 2, 3, 1, 2, 3, 4, 5. There we go. So those are my 2 points, right? So if I wanted to calculate the rise and the run, I could count, but I could also kind of look at my coordinates, right? So if my rise is on my y-axis, so I'm at a 2 here on the y-axis, I'm going up to a 6, right? So without graphing it, how could I figure out what that distance is? Well, I'm just finding the difference between those 2 points. I'm going to subtract. So I could do 6 minus 2. Okay, that's going to get my rise. And then my run, well, I'm at 0 on the x-axis, and I'm moving over to 3 on the x-axis. So how far apart are those? Well, if I subtract, right, that'll tell me my run. So if I simplify that, 6 minus 2 is 4, 4 over 3, that's my slope. Okay. Now, there's a kind of a formula that goes along with that. So rise over run. Okay. Rise is the change in the y's. Run is change in x. Okay, now there's a couple ways you might see this written. When you want to talk about difference or change in math, sometimes you see a triangle symbol used. Okay, so you read that as the difference in y, the difference in x, basically is what that means. A lot of times you'll see this written also like this. Okay. So we'd read that as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The little numbers there that kind of look like exponents, but they're on the bottom. It's just a way to kind of number things. Okay. So if I had 2 coordinates, let's say I had 1, 4, and 5, 7, for example. Okay. This would be my first x, my second x, my first y, my second y. Okay. So again, what we're basically doing is we're finding the difference in the 2 values, okay? We do the y on top because y goes up and down. That's our rise, right? The y-axis goes up and down. X is run, it's our x-axis that goes sideways, okay? So if I was using this formula, I'd go take my second y value, 7, minus my first y value, 1, and then my second x value, 5, minus my, oops, I messed that up, didn't I? That should be a 4, my bad. Second y minus first y, second x minus first x. There we go. Simplify that. 7 minus 4 is 3. 5 minus 1 is 4. There's your slope. Okay? All right. So change in y over change in x. We want to subtract our y values to get our numerator, to get our rise. Subtract our x values to get our run. Okay? You guys want to take the second one minus the first one. Okay. Again, if it comes out to be 2 negatives, let's do one more of these. Let's say I had 5, 8, and negative 1, 2. Okay, actually, let's make that a negative 5. There we go. All right. So in this particular case, again, I want to subtract my y values. So my second y value is 2. My first y value is 8. Okay. And then at the bottom there, my second x value is 1. my first x value is -5. Okay, so you got to be careful of your negatives here, right? 2 minus 8 is -6. -1 minus -5. Remember, when we subtract a negative, we change that to plus a positive. All right, -1 plus 5 is +4. Okay, and then I could simplify that down into -3 over 2. Okay, -3 over 2. All right. Now what I meant to do, I'm going to change this here. So let's say instead of -5, this was now +5. Oops. So let me fix these. So the numerator wouldn't change, right? It'd still have 2 minus 8, but now it'd be -1 minus 5, right? Which would make my denominator -6. Okay? And then a negative and a negative in a fraction cancel each other out. And 6 over 6 would simply simplify down into 1. Okay, so we'd say our slope in that case would be 1. All right. So we have our slope from 2 points, right? We can calculate our slope if we know, or if we have the graph, we can kind of rise over our run. And then if I know the slope and I know 1 point on the graph, I can graph that line using that information. Okay, again, slope is just the rate of change that exists, right, on a linear equation, an equation that's a straight line. It's going to have that stair-step effect. You're going to get the rate of change to be the same. Every amount you go over, you go the same amount up each time. So that gives you that rate of change.